Good afternoon, and welcome back to another lesson in AP Statistics. We are continuing on in Chapter 5 today, and when we go moving on to Section 5.2, we will learn about some basic probability rules. Some of these rules will be a review from the very first chapter, and some of them we will build off the rules from the first chapter to expand on them. In our last section, we looked at simulations to imitate chance behavior. Fortunately, we don't have to rely on simulations to determine a particular probability. Instead, we're able to calculate it as long as we have a sample space. A sample space, which is dictated by the capital letter S, is the set of all possible outcomes. And in every probability model, which is a description of some chance process, consists of two parts. We have a sample space S and the probability for each outcome. The example we're looking at in today's lesson is rolling two six-sided die. So I have an orange die and a blue die, and I'm going to roll each one. And the sample space is all of the possible outcomes of rolling these two die. So since there are 36 total outcomes, my sample space is 36. Since each of the dice are fair, each outcome is equally likely. So every outcome that you see has a 1 out of 36 probability of occurring. Now, probability models allow us to find the probability of a collection of outcomes. And we look at this by looking at events. An event is a collection of outcomes from some chance process. Now, we look at events as capital letters like A, B, C, and D. So if I had an event and I called it event A, then P of A is the probability that event A occurs. So if my event is rolling two die and getting a sum of 5. So event A is getting a sum of 5. That means that I'm looking at the probability of getting a sum of 5 when rolling two die. So I'm going to look at every possible outcome of getting a sum of 5. It should be a 1 and a 4, a 2 and a 3, a 3 and a 2, and a 4 and a 1. Now I just want to be clear, a 2 and a 3 is different than a 3 and a 2 because these are two distinct die. Therefore, the probability that event A happens is 4 out of 36, since each outcome is equally likely to occur. If event B is defined as the sum is not 5, then we would be looking at its complements, which would be 1 minus that the sum is 5. So that'd be everything else in the sample space. So that'd be 32 out of 36. Here are some basic probability rules. The probability of any event has to be between 0 and 1. 0 meaning 0%, 1 meaning 100%. All possible outcomes together must have a probability whose sum is exactly 1. Okay, so if we add up all the possible outcomes, we should have a possibility of exactly 1. If all outcomes in the sample space are equally likely, then the probability that event A occurs can be found using the formula by just counting the number of outcomes corresponding to event A divided by the total number of outcomes in the sample space. So I like to call it success over sample space, and a success meaning what is event A? Event A is the success. The probability that an event does not occur is 1 minus the probability that the event does occur. We call this the complement of an event. And if two events have no outcomes in common, the probability that one or the other occurs is the sum of their individual probabilities. Now we can take all of these rules and write them into shorthand, which we'll see in the next slide. Let's talk about mutually exclusive events first. That last rule that says if two events have no outcomes in common, then the probability that one or the other occurs is the sum of their individual probabilities. Well, that means that these two events are mutually exclusive. If they have no outcomes in common, then they are mutually exclusive. For example, my birthday is on March 31st. Mr. Vita's birthday is on March 27th. If I was to pick a random day of the year, the probability that it is both mine and Mr. Vita's birthday is 0 because it can't be both March 27th and March 31st. Are those two events, event A being it's my birthday, event B being it's Mr. Vita's birthday, those events are mutually exclusive. They cannot overlap. Here is the shorthand for all of the rules that we just had. Because the probability of event A is between 0 and 1. The probability of the entire sample space is equal to 1. The probability of A complement is A to the power of C, which is just 1 minus the probability that A occurs. And then if events are mutually exclusive, we can add the two total probabilities together because they do not overlap. They don't share any overlap, much like me and Mr. Vita's birthday. We can look at probabilities in a two-way table. Here's a two-way table, and we're looking at 178 students, and we're looking at their gender and whether their ears are pierced. So part A says, what is the probability of selecting a student at random and the student has pierced ears? So we're looking at just the pierced ears column. So 103 students have pierced ears, and the sample space is 178. So the probability that event B occurs, which is pierced ears, is 103 out of 178. Part B says, is a male with pierced ears? So now we're looking at just the number 19, because we're picking a random student, and we want to know what's the probability that they are a male and have pierced ears, which would be the 19 out of the sample space, 178. And C is a male or has pierced ears. So this is where we have a male with pierced ears, a female with pierced ears, and a male without pierced ears, because is a male or has pierced ears. So any of these three. Okay, you'll notice that this has overlap, right? Because 19 could be counted twice. So we have to be aware of that when we're dealing with non-mutually exclusive. So these are inclusive events, okay? Because you could be both male and have pierced ears. We can mimic probabilities in a Venn diagram, like you see here. And we're going to look at the example we just talked about and how those two events were not mutually exclusive because there was overlap. So in order to find the probability of one or another event happening, like A or B, we just had male or pierced ears, we can't use our mutually exclusive addition formula where it was just add the two probabilities together. Because there's overlap, we're going to have to add the two probabilities together and then subtract the overlap, because otherwise this overlap will be counted twice. This formula is on your formula sheet. You have to just be able to use it. Okay, so we are just looking to see if things are not mutually exclusive, we have to use this general rule for adding two events. Here is some standard vocabulary and notation about Venn diagrams. So here we have A, and then we have A to the power of C. A to the power of C is A complement. So this would be everything that's not A. Okay, so anything not A is the complement of A. If A and B are mutually exclusive, another word you might hear from mutually exclusive is the word disjoint. If they are disjoint, they do not have any overlap, just like my birthday and Mr. Vita's birthday do not have any overlap, then the two Venn diagrams will be separated. When looking at Venn diagrams, if we're looking at the intersection of two Venn diagrams, you would see it as A intersect B, which looks like an upside down U. That would be the that would be, thank you for anyone who blessed me. So A intersect B would be the intersection, the middle, the green parts of this Venn diagram. A union B means A or B. So that means you can be in A, you can be in B, or you can be in both A and B. So that would be all of the green represents a union B, and it's represented by a U shaped in between the A and the B. Okay. And we will go over some examples in class together. And I hope you are enjoying these short videos because I am